In our next section, in Unit 4, we need to talk about what happens when we're dividing by surds, or we have that radical in the denominator. These are a couple examples. We might have 3 over the square root of 5. There's our radical. We might have 3 plus the square root of 5 over 1 plus the square root of 5. It doesn't have to be the square root of 5. These are just 2 examples that happen to use that. And if you look at the last expression, the radical in the denominator is the square root of 12x. So anything that has a radical in the denominator means that you are dividing by a surd. To do this, it's a special process. When we simplify, there should not be any radicals left in the denominator. None. So our process is called rationalizing. Rationalizing is when we get all the radicals out of the denominator. To rationalize, think you're undoing the radical. So if you have a square root of 5 or a square root of 8 or whatever it is in the denominator, you're going to want to undo that radical so that you can divide. That's how you divide. So let's look at a couple examples. This first example is 3 over the square root of 5. So we have to think about how to undo this radical. If we have the square root of 5 and what we want to get rid of is the square root of 5, then we want to multiply by the square root of 5. That will get rid of the radical. 5 will stay, but the radical will go away. And in a fraction, we can't just do whatever we want. What we do to the bottom, we must do to the top. So we multiply the top and the bottom, the numerator and the denominator, by the square root of 5. Now, when we do this, we use our rules for multiplying surds. If we have 3 times the square root of 5, 3 is not under a square root. 5 is. That means 3 stays outside and 5 stays under. Now, the 2 square root of 5 in the bottom, you can think about it 2 ways. This is under a radical and this is under a radical. So we could have the square root of 25. We can multiply those together. Or, if you're comfortable with it, multiplying the square root of 2 numbers. The 5 and 5 are identical, and they just have a square root. The square roots would cancel, and you would end up with a whole 5 on the bottom, and that would be your final answer. Either way, when you take the square root of 25, you're still going to get a whole 5. That's rationalizing. We have gotten there's no longer a square root in the denominator. It is just a whole 5. That would be your final answer. Square roots in the numerator are fine. Let's look at another example. This time we still have square root of 5 in the bottom, but we have 2 things in the top. I couldn't think of the word. We have 2 numbers. We have 3 plus the square root of 5. So same process as before. Our goal is always to get the radical out of the square root. So to undo the square root of 5, we want to multiply by square root of 5. Whatever we do to the bottom, we must do to the top so that we are not making a brand new problem, but just making it equivalent, one that works for us. When we multiply these, square root of 5 times square root of 5, we can say that that's square root of 25, or just the whole number 5, but the radical must go away if you write a 5. On the top, you have to be careful here, because what happens is since we have 2 numbers here, 2 terms, the square root of 5 is going to have to be distributed. So we have 3 square root of 5 plus another square root of 25. Also be careful here. Yes, these 2 things are the same, but they cannot be canceled because the one on the top is added. If it is added, it cannot be canceled. Only if it's multiplied. So finally, we have 3 square root of 5 plus 5 over 5. And this would be your final answer since we no longer have a square root in the bottom. You cannot cancel out these 2 5s because the 5 on the top is glued together with that plus. That plus means that it cannot move. If you wanted to divide this 5, there would have to be a whole 5 here and here. But since there is not, you cannot divide it. You cannot break up the fraction like that. Let's look at another example. This time we have two terms in the top and two terms in the bottom. So this process is a little bit different. When we look at the bottom, we can't just multiply by the square root of 13 because when we distributed it to that 2, we would have 2 square root of 13 and the square root would still be there. So what we have to do in this case, when there are two terms in the bottom, it's a little bit different. We have to multiply by something called the conjugate. A conjugate, it means opposite. And to get the opposite of a term that looks like 2 plus square root of 13, the conjugate of this would be 2 minus the square root of 13. That's our process. That's how we find the conjugate. So our conjugate is this. So instead of multiplying by just the square root of 13, we need to multiply the top and the bottom of this by the conjugate, which is 2 minus the square root of 13. Only the sign in front of the radical changes, not the sign in front of the whole number. 2 was positive up here, so it stayed positive when I multiplied. If it was negative, it would have stayed negative when I multiplied. But the sign in front of the radical changes. So now what you have to be careful about is you have two terms and two terms. When you are multiplying these, you have 4 terms that you're multiplying, 2 binomials, which means you need to FOIL. So we have 2 times 2 on the top is 4. 2 times negative square root of 13 is negative 2 square root of 13. Now we need to multiply the negative square root of 7 and the 2. And we get negative 2 square root of 7. And then the last two multiplied, both of these are under a square root, so it gives us a positive square root of 7 times 13 is 91 over, now we do FOIL on these 4, so 2 times 2 is 4. We have 2 times negative square root of 13, negative 2 square root of 13. Positive 2 times square root of 13 is positive 2 square root of 13. And then we have the square root of 13 times the square root of 13, which is either a whole 13 or a square root. That would be a negative because we have a positive and a negative. 169. From here, it's simplifying. So we have a plus square root of 13 and a minus square root of 13. Those cancel. So we have, don't know what happened. Let's fix that. Okay. So we have on the top, we don't have any square roots that are the same. So we have 4 minus 2 square root of 13 minus 2 square root of 7 plus the square root of 9, d1, all over the square root of 169 is 13. So we have 4 minus 13, which is a negative 9. This looks long, but this is your final answer because square roots can only be added or subtracted if these are the same. And all of these are different. We have a square root of 13, square root of 7, and square root of 91. So even though that's long, that is our final answer. Let's look at one more example. We need to look at the square root in the bottom. The square root in the bottom here is the square root of 12x. So to undo that square root, we are going to multiply by the square root of 12x. What we do to the bottom, we must do to the top. So we have a 3 square root of 12x times square root of 12x is a whole 12x over 15 stays out front. And under that, we have 60 times 12 is 720. And we have x to the 5th times x is x to the 6th. Now it's just simplifying. 15 divided by 3, we can do that. We would have a 5 up top. Square root over, and we will leave the 12x. We need to simplify this square root. So 720 we can say that that is, think about any square roots that go into 720. So 720, 36 times 20, and x to the 6th. If there are any other square roots, we can take the square root of 36. There are other square numbers we can take the square root of that go into 20. So leave the 5. We can write this as 36 times 4 times 5, x to the 6th over 12x. So we have 5 times the square root of 36 would be 6, so that's outside of the square root. The square root of 4 is 2, that's also outside of the square root. And we cannot take the square root of 5, but we can take the square root of x to the 6th. Our shortcut is that a square root says that we have the whole number. A square root has an invisible 2, so we divide by 2. That is x cubed. And the 5 is left over under the square root. 12x. And we can cancel these out. 6 times 2 is 12. Those can cancel. X cubed and x. X would cancel. This would go down to an x squared. So this is 5x squared, square root of 5. That's our final answer.